All right, back with Geometry, Chapter 11, Lessons 1 and 2. This is mostly a review. An area addition postulate, 11.1. The area of a region is the sum of the areas of its non-overlapping parts. All right, so here we go. Area of a parallelogram. This is not new. This is old hat right here. Area is base times height. Remember that the height is always perpendicular to the base. Postulate 11.2 is the area addition postulate. If two figures are congruent, then they have the same area. All right, area of a triangle. Also not new, either a half base times height or base times height divided by 2. I prefer this form because usually when we're solving, this is easier to see. We have to multiply by 2. Again, remember, base and height are at a right angle. Find the perimeter and area of a parallelogram. Remember, for the perimeter, we just add up the sides. And in a parallelogram, the corresponding sides are congruent. So this is also 10 over here, like this one. And this is 4 and 4. So add those up. And that gives us the perimeter of 28 inches. And then the area is just base times height. Now, there's the height. This is perpendicular on this side, which makes 10 the base. Okay, I can't use 5 and 4. Careful there. They're trying to trick you by putting the 4 at the bottom there. Base is not always at the bottom. Base and height are always at a right angle. Base and height, angle is right. So 10 times 5, and that is 50 square inches. All right. Area of a trapezoid. Area of a trapezoid is the average of the two bases. So base times height divided by 2. Base 1 plus base 2 divided by 2 times the height. Now sometimes written like this, 1/2 height, but I prefer writing it like this. I say that's, oh, come on. Here we go. Base 1 plus base 2 over 2 times the height. That way we can see it's when we average these two out, if I make this longer, make this shorter, now I have a rectangle, and now I can just do base times height. So that's where we get that. Average of the bases times the height. All right, area of a rhombus or kite. This one is new, so make sure you write this down. The area of a rhombus is 1/2 the product of the lengths of the diagonals. So you multiply the diagonals, diagonal 1 with diagonal 2, and divide them by 2. Diagonal 1 times diagonal 2, and I would probably write it like this, diagonal 1 times diagonal 2, 1 over 2. Okay, a little bit easier for working it out this way. Then you remember to get rid of that, we multiply by 2 if we're solving for one of the diagonals. Same thing for a kite. Diagonal 1 times diagonal 2 divided by 2. All right, so we know one diagonal of a rhombus is twice as long as the other diagonal. If the area of the rhombus is 169 millimeters squared, what are the lengths of the diagonals? All right, we know it's half of the product of the diagonals. So one diagonal is twice as long as the other. We'll call one x, the other one 2x, because it's twice as long. 1/2 times 2 cancels out, so we just have x times x, and that gives us x squared. That is 169. Find the square root of that, and that is 13. So x is 13. Multiply that by 2 to get to the long side, and we get 26 for that one. Okay, here's the summary. If you want to copy this down to your notes, especially this one right here, this is the new one, and I know this one can be tricky at times. Again, quick reminder, this is how I do it. I like to think of it as the average of the two bases times the height, but whichever way you approach it, that's up to you. So there we go. That's all we have for today. See you in the next screencast.